Hi, in this video, we are discussing the seventh numerical from the chapter Units and Measurements, which is the first chapter for 11th standard physics. And let's get started. तो क्वेश्चन में हमसे पूछा गया है टू फाइंड द परसेंटेज एरर in calculating the kinetic energy of a body whose mass is given to us, which is 60.0 plus or minus zero point 0.3 grams, where plus or minus zero point 0.3 grams is the absolute error involved in the measurement of the mass. And then we have also been told that this body is moving and with a velocity that is said to be 25.0 plus and minus 0.1 centimeters per second, where plus and minus 0.1 is the absolute error involved in the measurement of velocity. So as you can see, since the quantities which we'll use to derive the kinetic energies has errors in their measurement, our kinetic energy, our calculated kinetic energy is also bound to have some errors. And उस error का percentage error हमें find out करना है in this particular numerical. With this, we have decoded our question. Now let's get started in the solving side of it. So सबसे पहले हम लिखेंगे all the given data that's been given to us in the given section. So let me quickly prepare our given section and then we'll write all the data that's been given to us. Now what are the data that's been given to us? Well, हमारे जैसे आप क्वेश्चन में देख सकते हो दो जगह पर न्यूमेरिकल वैल्यूज है. फर्स्ट हमें दिया गया है मेजरमेंट ऑफ मास. So this measurement of mass is represented as the mean measurement plus and minus the absolute error जो इस mass की calculation के वक्त हुआ था. तो इसमें we have been given 60.0 plus and minus 0.3 and the measurements were done in grams, not in kilograms but grams. And second quantity जो हमें दिया गया है that is the velocity. So similarly हमें mean velocity भी दिया है and also the absolute error associated with that measurement, that is delta V, and this is given to us as 25.0 plus and minus 0.1 centimeters per seconds. Now usually what we do is कि जब भी हमारे पास ऐसे units आते हैं centimeters per second या gram, we try to convert it into standard units. But हम जब देख रहे हैं percentage error, so percentage error is more like a ratio and generally उसमें कोई units होता नहीं है, and when we solve this you'll notice that these units will get balanced off. So we can use that information to our advantage and not convert this, and we can just use the CGS unit to begin with. So that's why we are not converting the units. And with this, we are done with our given section. Now let's move on to the next sub part of the solution, that is to write to find. So I'll just quickly prepare our to find section. So to find, and in the question what are we required to find. So अगर आप question में देखोगे so हमें जो है ये percentage error ढूंढना है in the calculation of kinetic energy. So I'll just quickly write the quantity which we have to find. एक ही quantity ढूंढना है, that is the percentage error. So percentage error in kinetic energy. So let me represent kinetic energy by the symbol E. Let me use a different ink. So I am representing kinetic energy as E. So when I'm calculating kinetic energy, उसमें क्या errors आ सकता है in terms of percentage error. So that's the only quantity that we are required to calculate in this numerical. So we'll move on to see what sort of formulas we can use to find this quantity. So we'll write our formulae section. Formulae. Okay. So हमें ढूंढना है परसेंटेज एरर, एंड हमने परसेंटेज एरर ढूंढने के फॉर्मूलेज देखे हुए हैं. बट हमें पता है कि बिफोर कैलकुलेटिंग परसेंटेज एरर, सो परसेंटेज एरर जनरली इज गिवन टू अस एज परसेंटेज एरर का फॉर्मूला इज रिलेटिव एरर. सो हमें जो है काइनेटिक एनर्जी का रिलेटिव एरर, जिसको हम ऐसे रिप्रेजेंट करते हैं, ढूंढना है, एंड देन उसको हमें 100 से मल्टीप्लाई करना है. दैट इज हाउ वी गेट परसेंटेज एरर. बट At this point, we have no idea about what the relative error is for our kinetic energy calculation. So first step would be to calculate the relative error. Then what sort of formula can we use to calculate this relative error? Well, हमने relative error का formula पता है. If I were to find delta E upon E, it would be the addition of the relative errors in the quantities from which this kinetic energy is derived. So since our kinetic energy का जो formula होता है, so kinetic energy is equal to half of mv square. Now इस particular equation में this is constant and it does not have any error. So the only errors is possible is in m and v square. So relative error for m is given as delta of m upon m. Okay, so this is the absolute error in m divided by the mean value of m, and we are adding, now we have to add the relative error in v square. So relative error for v square is 2 times the relative error of normal v, that is delta v upon v. So this is the relative error which will be in our kinetic energy, and we'll calculate this first, and then we'll substitute this value of E in our percentage error ka formula to get the final percentage error. And that's it. We are done with the formulas, only 2 formulas, and हमारा जो result है वो आ जाएगा. So now the only step that's remaining is to do the actual solving part. So let's get started. I'll quickly write the solution section for our numerical and we'll get solving. Okay, so this is our solution section. So सबसे पहले आई कैन से सबसे पहले हम relative error ढूंढेंगे kinetic energy का. So from formula 2, because that's the formula जहाँ से हमें kinetic energy का relative error मिलेगा. So I can calculate delta E upon E. So I'll quickly also write that this is relative error in E, so that we know what are we calculating. So if we were to substitute the given formula, given values, so delta m is given to us as 0.3 and m is given to us as 60. So the first counterpart is 0.3 upon 60 plus 2 into, now this is delta v upon v. So delta v ka value is 25.0 and delta v ka value is 0.1 and v ka value is 25.0. So I'll substitute delta v ka value as 0.1 and v ka value as 25.0. Also the value of m is 60.0, because since we are in units and measurements, significant numbers does matter, so that's why we have to make sure we write the entire decimal value. ओके, सो हम क्या करेंगे, हम न्यूमरेटर और डिनोमिनेटर को 10 से मल्टीप्लाई कर देंगे. सो हमारे वैल्यूज विल बी 3/600 प्लस 2 into 1/250, dividing by 3 at numerator and at denominator. So we get the fraction simplifies as 1/200, and then यहाँ पे 2 ones are and 2 125s are. So 1/125. And if we were to add this, we would get the value as, now if we were to solve this term, we would get 125 plus 200 divided by 200 into 125, and solving this further gives us 0.013. So that's the value, and basically this is our relative error in kinetic energy, so that is delta E upon E. So this was the first half of the question which we needed to solve, because now we need to substitute this value of relative error in our first formula, that is the percentage error formula, to get the required value, that is the percentage error. So from this we can say from formula 1, we can calculate the percentage error involved in the kinetic energy. So from formula 1, we can say percentage error. So I am just using the short form for percentage error is equal to delta E by E, that is the relative error in kinetic energy, which is given to us as 0.013, which we just calculated, into 100. And if we were to do this, we would get our percentage error as 1.3%. So this is our final percentage error. And this is what we were required to calculate. So this is the final answer. So a total of 1.3% is the percentage error involved in the calculation of kinetic energy. That's the final answer what you have to write. And with this, I hope it helped you. Thank you. Also, the PDF of the solution is mentioned in the description, so do check that out as well.